Hello and welcome. I'm going to take you on an archaeological journey with some help from my friends at Wessex Archaeology. Now it's our job to uncover stories from the past and bring them into the public domain. But as archaeologists, it may appear like our work mostly involves being muddy and using spades and trowels to reveal our history, but the world of commercial archaeology is steeped in cutting-edge science, technology, engineering, and even maths. So join me as we find out, what is Wessex Archaeology? We might think that the presence of archaeology is limited to solid ground, but did you know that archaeological sites exist under the sea? Before an offshore cable route or even a wind farm can be put in place, our marine geophysicists must first check for signs of archaeological potential beneath the waves.
Marine geophysics is a remote sensing technique that helps us find archaeology on and below the seabed. In marine geophysics, there are four main sensors we use. The first is a multibeam echo sounder. This emits an acoustic wave. From the time it takes for the sound to travel to the seabed and back, we can work out if there are any large objects standing tall from the seabed, such as a shipwreck. The next is side-scan sonar. This also uses sound, but instead of listening to the time it takes for the sound to travel back, it listens to the strength of the return signal. This helps give us clues on the material of objects on the seabed. For example, a metal shipwreck will reflect more of the sound than a shipwreck made of soft, waterlogged wood. We also use marine magnetometer. This detects changes in the Earth's magnetic field, so we can work out whether objects on the seabed are made of materials containing iron. And finally, we have sub-bottom profilers. These send out an acoustic wave that penetrates the sea floor. When that sound wave hits a horizon, which could be a change in sediment type or the edge of an old river channel, it reflects some of that sound back. From the return sound, we can begin to map out and build a picture of a drowned landscape that might have once been home to humans many thousands of years ago during periods of low sea level. Using all these tools, we can begin to work out the archaeological potential of features under the sea, from prehistoric landscapes all the way to wartime shipwrecks. It's important we find any archaeological features ahead of construction work, such as building offshore wind farms. Once we've found the potential archaeological sites, we can recommend ways to protect them, such as using exclusion zones to prevent them being damaged.
The role of a coastal and marine archaeologist is an exciting one. Guided by the results from the marine geophysics, our deep-diving archaeologists preserve, rescue and record our submerged heritage through some unique and familiar methods.
The coastal and marine team work with any archaeology related to the sea or coastline. These sites can be intertidal or completely submerged. Our work includes diving, using an ROV, intertidal excavation, conservation management plans, and we also work with the offshore wind and aggregate industry to protect our submerged heritage. For some wrecks, remains of the actual vessel are no longer there, as the underwater environment is harsh on materials like wood, but finds made of other materials like this cannon can survive well. Just like archaeologists do on land, we record everything we can by taking lots of photographs, video footage, and to some people's surprise, we take measurements and notes underwater by using a pencil and special paper. Similarly, we can also metal detect underwater to search for hidden metal finds. This is useful when marine growth is very thick, like the kelp in this video. Some of our work is affected by dark or silty waters where visibility is impaired. We call this low visibility. The Thames featured in this video is notorious for having dark, murky waters. The Coastal and Marine team also have a remotely operated underwater vehicle, or ROV, which is sometimes used instead of divers when sites are deeper or more dangerous. In this clear footage from a loch in Scotland, we can see 2 anchors and a cannon. Not all our work is ship-related. There are also several aircraft wrecks dotted around the coast, and we work on some of these too. In 2019, we helped raise a ferry barracuda and donated it to the Fleet Air Arm Museum. Not all our work is wet. We also design conservation management plans for historic vessels like HMS Trincomalee that need to be cared for and preserved for future generations. We also conduct intertidal excavations, which are a lot like excavations on land, with the added difficulty of wet, thick mud and the pressure of working in a short tidal window before the tide comes back in. Marine mud preserves finds made of wood and organic materials such as rope very well. Therefore, we expect lots of finds on excavations like these.
When we uncover archaeological remains, we want to know what type of environment past people were living in. Were they living near water? Was there shelter? What did they survive on? Geoarchaeology is able to provide these answers by taking samples from the ground. So let's find out more.
As geoarchaeologists, we use techniques that are usually associated with geography and geology to understand the archaeology. We do this in two ways. First of all, archaeology is buried in the ground, so we need to have an understanding of the different types of ground the archaeology is buried in, as this can have an impact on what's preserved. Secondly, people are very reliant on the environment they live in, as it provides water, food, and material to build shelters. We know climates and environments were different in the past and that they change through time, for example, the Ice Age. So as geoarchaeologists, a lot of our work focuses on reconstructing the landscapes and the climates of the past. We need to get samples from the different types of ground, which we do by either digging trenches or by drilling into the ground with a long tube and then pulling out a core sample. In these core samples, we capture all the different layers of ground that have built up through time. Once we have these samples, we can analyse them to see what environment they formed in. For example, did the environment used to be a river or was it a beach? And then we can look at all the tiny microfossils in the samples and we can see what types of plant were growing there or what the water quality was like. For example, was it fresh water people could drink or was it salty seawater? And we can find out exactly how old the ground is by dating it with methods such as radiocarbon dating. All of this information helps us build up a better picture of what life was like for our ancestors in the past.
Having done our research and interpreted our geophysics, it's now time to start digging. Excavations allow us to dig into the ground to confirm the presence or even absence of archaeology. Excavations can take us all over the country, from the more rural settings to the thriving hustle and bustle of a big city. Different approaches are required depending on the type of archaeology that we expect to encounter. And all of this is guided by the historic research and the geophysics results that we've done beforehand. We target our trenches to reveal as much archaeology as possible, and we treat the machine bucket just like a big yellow trail as we guide it down through the soil until we've reached the first archaeological horizon. Using our hand trowels now, we move aside the soil and earth to uncover and reveal archaeological features. This site was in Sheffield city centre and the team are revealing some really lovely Victorian furnaces and other industrial structures. Once the features are clean, we record them, and this part is very important as it becomes a permanent historical record. From our research, we knew that the remains of Sheffield Castle lay beneath years of 19th and 20th century rubble and buildings, and thanks to our excavations, we have been able to discover more about this important and historic site. As you can imagine, making the best archaeological record possible is very important. So we use some very technologically advanced pieces of kit to do this in our geomatics team.
Geomatics covers a wide range of techniques involved in recording and analysing different kinds of spatial data. There are numerous methods of recording spatial data, including remote sensing, photogrammetry, topographic and walkover surveys, as well as terrestrial laser scanning. UAV photogrammetry is an excellent example of how new technologies enable us to rapidly record archaeological landscapes and features. This technique involves taking several overlapping photographs which are then processed through software which analyses the space between pixels to generate a 3D model. We can also use photogrammetry to record smaller items such as finds and artifacts from across our sites so that they may be presented to the public. In this example, you can see an early medieval tiled floor from our excavations at Bath Abbey. We also use techniques such as laser scanning to record complex structures, like these crucible cellars in Sheffield. Geomatics offers many opportunities to learn advanced surveying techniques that are employed across many different industries.
As archaeologists, we often get asked, have you found any gold? And if we did, the finds room is where we would take it. So let's take a look.
The Finds Department at Wessex Archaeology is the first destination for all finds recovered from our sites. When finds first arrive in the department, they are cleaned according to the material type. This could include finds from any period, from the Neolithic to the Roman period to the 20th century, and can include a wide variety of materials such as pottery, flint, animal bone, metals and glass, as well as human remains. Finds are stored in a warehouse facility until they are analysed and reported on by the team of finds specialists at Wessex Archaeology. The finds are bagged and boxed according to the guidelines issued by the museum that is going to have them when the analysis is finished. The specialist will look at the material and determine the range of types and dates present, and may well compare the finds with similar items from other sites. When there are large groups of pottery, the specialist will try to join the broken sherds to try to reconstruct the vessels that made up that group. This work all helps to build up a picture of what was happening on the site so that the full report can be produced.
Just as finds can help solve pieces of the archaeological puzzle, so too can environmental remains. Here we can discover what plants were growing in the Stone Age, or even how much charcoal they were using in their cooking.
Environmental archaeology helps us interpret the landscape of the past and how people interacted with it. All these buckets are full of soil from archaeological features. They'll be processed to collect any environmental material, like the remains of plants and wood and snails. Each bucket has a label that shows us exactly where the soil came from, which site and which feature. We add water and hydrogen peroxide of the sediment's very clay to the sample and use this, with a constant flow of water in a tank, to gently break down the sediment, like Jenny's doing here. This washes the sample so that what we're left with is the environmental material, which we call the flot because it floats, and things that don't break down, like stones and fines, which we call the residue. Once the flot and residue are fully dry, they can be looked through to pick out the environmental remains for identification. We put them through sieves of different sizes to make it easier to sort through the material. The residue is looked through by hand, and the flot is sorted under a microscope.
The studio is where we really bring the past back to life. Each of the previous departments have given us more information about the site, and now it's time to recreate it. Imagine stepping inside a Roman villa and exploring each room through a virtual world. Our studio team have created this reconstruction based on real features and artefacts. This virtual Roman villa is based on the results of our excavations. Rather than recreating entire worlds, we may want to capture important finds from a site instead. Our 3D scanner takes high-resolution images, accurately capturing details of even the most delicate finds, and once processed, we have a fully rendered 3D object. For some objects though, like this Roman brooch, the best way to capture its incredible detail is by drawing it by hand. And we may also want to show the type of people who lived in that period and maybe have even worn that brooch. It's not just archaeology that our studio is good at. We have photographers, filmographers, illustrators, and 2D and 3D animators that together enable us to make documentaries and animations and publications and even films like this. And this is Hazel. She's the newest member of our studio team. Hazel is our 3D animated archaeologist. She has a lot to say about the past, and you might even see her on YouTube. This film has shown you the many exciting and varied departments within Wessex Archaeology, and how our work of bringing the past to life couldn't be done without using science, technology, engineering and maths. So the next time you find yourself in the classroom doing long division, wiring a circuit, or maybe setting up flasks for an experiment, just think, could you be learning the skills of a future archaeologist? Wessex Archaeology is an educational charity. To find out more about how archaeology can support STEM learning, as well as a range of other subjects, visit our website or contact the Community Engagement team on engagement@wessexarch.co.uk.